So what I'm trying to show here, some of the digital actions that we are doing at ICARDA, and especially the digital solution that is targeted for smallholder farmers. This is not very much related to carbon-related things, but since we are involved in this project and we are also having some digital actions, we thought we could synergize this somehow. So back in 2020, there was a large regional stakeholder consultation and on how to develop a regionally relevant climate action program. And we were instrumental in bringing together close to 500 policymakers and various types of stakeholders from around 20 countries in the region. And digital actions came out as a very important action area where climate action can be, climate action, be it adaptation or mitigation, can be accelerated. Of course, a lot of technologies are there, but it's not happening in an accelerated pace. This is a need for digital actions. So just showing how ICARDA is doing digital actions. There are two areas in which ICARDA is having role in digital. One is digital innovations, like the scientific part of digitalization, like machine learning based crop modeling or machine learning and AI based soil moisture estimation. And in addition to the conventional digital actions like remote sensing, climate analytics, modeling, etc. So that's the science part, but we need to take science part to the stakeholders. This is where digital platforms and apps and things like that are developed. So there are two axes of our digital action. So some examples are shown here, like we helped the World Bank to understand how they could invest in Iraq, for example, in the climate change, climate smart agriculture. We have been also helping the World Bank to develop investment blueprints for Jordan. All these are based on modeling approach, stakeholder consultations, etc. So this is another example showing climate analytics, understanding the hotspots and where we could deploy relevant climate actions. So, and we also have a lot of models, especially distributed models. This is an example of a model that I developed during my PhD 25 years ago. We have models of carbon, water, nutrient, and nitrogen cycles. So what I'm trying to show here today, the focus is a tool that we developed at ICARDA to help smallholder farmers of Egypt. So the problem here is that farmers have to raise crops what we call in a sustainable way. That's what we call it, a sustainable intensification. We have to intensify crop production, but it has to be in a sustainable way. That means optimizing water use, labor use, nitrogen use, all the inputs have to be sustainably used. At the same time, we have to opt for climate smartness. For example, we need to reduce nitrogen use, or we have to reduce carbon emissions because by techniques like conventional tillage, water usage, enhancing water productivity. So, but the problem is that we need to optimize between climate smartness and sustainable intensification. So it's a challenge. So farmers really don't know, especially in farmers in the global south don't know what are the location-specific interventions they need to have. And also this problem is aggravated by the lack of extension system, especially in Egypt. The extension system is weak, and this has to be strengthened using digital technology. So that's the motivation. And of course, we know there's a plethora of digital tools existing. There is a digital tool for disease prediction. There's a digital tool for water stress or water irrigation management. There's a digital tool for other things like choosing the right pesticide, etc. But we need a one solution that farmer can have. The entire activities of agriculture can be got from it, because farmers cannot install 100 apps in their phone and get. So this is where we came up with a solution. So at ICARDA, we have this GeoAgro tool. We have this tool operational in 4 countries. One is in Egypt, which is called the different words. We have different variants of the GeoAgro tool. For Egypt, we call it as GeoAgro Master. In India, we call it as GeoAgro iKrishi. In Central Asia, which is in specifically Uzbekistan, we call it as GeoAgro Dikon. And in Morocco, it is GeoAgro Morocco. All these are not just digital tools that are different in terms of language and look, but they are really different in terms of the crops and also the socioeconomic characteristics of that the target country, for example. In Morocco, for example, the app is developed in the Darija language, and the crops are mostly focused on Morocco-specific crops. Some in Central Asia, for example, there's an emphasis on livestock. Egypt is basically targeted to Egyptian situation. So how this tool operates is that this tool has several solutions. So if you could see this screen, the bottom right, this is basically the technical schematics where there's a central server where we get database, or we have the database of the farmers, we have the database of scientists involved, we have remote sensing analytics. The science part happens in the server, a centralized server. And around that server, 2 interfaces are created. One is a dashboard where experts and policymakers can understand the situation with a bird's eye view. They can analyze the technically detailed situation like remote sensing analytics, weather analytics, and things like that. They also can, using that, they can send advisories to the farmers in a targeted manner. They also can use, they can update the contents of the advisory. For example, for each crop, there are agronomic practices and there may be changes, errors in the advisory that can be fixed, or there could be new types of crop varieties, there could be new things. All those things can be updated. The content management can be done by the experts. There are also other services like weather forecast. Then there is a very key and unique feature, like farmers can ask a question in real time, and this question, a photo is needed, and this question from the app, it goes to the central server, and based on the type of question, it goes to the targeted expert. If it is a entomologist or a hydrologist or a policy-oriented scientist.
It's a digital expert or a live expert.
Yeah, that's right. This is happening in real time. And we are also incorporating AI-based approach, like you see sometimes we have different types of large language models are used. We use Gemini, we use ChatGPT, and also there's an interest from the UAE government to use their own LLM. So AI-based extension system is also happening. Then there is a possibility of citizen science where farmers can contribute to creation of a database collectively. Then there is a livestock module, there is economic analysis module. So there are, and also remote sensing module. You don't give a lot of complex details like NDVI, evapotranspiration, etc. to the farmer, but we distill that into simple analytics that can be appreciated by the farmer and taken. So these are some of the screenshots of agronomic advisory, how it looks like for different crops. We have in the different crops, you have different agronomic things like seeds, water management, nutrient management, weed management, pest management, harvest, etc., etc. So this is some screenshot shown here. There is also a module for peer-to-peer chatting. Farmers can learn from each other, and also with a group. The know your field is basically remote sensing analytics. We don't give, as I mentioned, we don't give a lot of remote sensing complex details, but we simplify it in this so that farmers can understand. Here there is a pest attack, or here this part of your field is stressed. Go and have a look at that. So farmers, especially when they have very large fields, they may not be able to understand how the field is health of the field. So this type of analytics may help. So this is a screenshot about the ask and exit. They ask a question, they instantaneously get a response.
What's the name of the software again?
This is called GeoAgro Master. Master, yeah. So these are some of the screenshots shown here. I'm not going to details, but I just want to show the team behind this. There's a team of scientists. There is also expert, the developers, remote sensing remote sensing scientists. Many people are there. So you can download a brochure with this QR code if you are interested further. So we have been, it's not just developing a comprehensive app. We have been, the last 3 years, we have been trying hard to scale this app across Egypt. So in this context, we have been doing trans-Egypt surveys, trans-Egypt capacity development activities by interacting with farmers with the help of the government of Egypt, that is Ministry of Agriculture and Ministry of Water Resources. And Rania can talk further on this. And we have tried to reach the many farmers, and farmers themselves will train other farmers, so that because this type of initial kickstart is needed for a solution to take effect. Yeah. So we also were here last year when there was a Agri-Tech for Egypt challenge, and we were shortlisted among the top 10, where around 800 participants were there from globally. So this is seems to be quite attractive, I think. We also have a lot of engagement with the government people, so that this can be really taken up by and also get endorsement from the various ministries. That's our target. What else? Yeah, we have similar to digital solutions other parts of the world. This is some pictures from India, where we have made some contributions, especially and also in Morocco. We just partnered with the National Institute of Agriculture Research and other National Extension System of Morocco. This is again in India. This is some screenshots about the Morocco tool. This is one interesting thing, that is the economic analysis. Farmers normally don't keep records of their the expenses they do on the field. Because of this, they really don't have a clear idea of cost-benefit analysis. So that, because we have created an option here where farmers can keep records of what they are doing, what expenses they are having on different types of farm inputs, so that at the end of the day, they can really analyze how they can minimize the cost. Because this is very important for farmers to maximize profits. So economic analysis is also one important thing in this tool. Yeah, this is the Central Asia. It's Central Asian version. This is in Russian language. Yeah. So that's from my side. My colleague Rania can talk more on how we are engaging with the Ministry of Agriculture. Ministry of Agriculture has taken up this as an action point in their next, in the future way in which they do extensions. So Rania.